My name is Jeff Varney. I'm the area manager for Clay Valve Company, and we're going to review the 16-inch pressure reducing valve. This is a model 90-01. It also has the X144E flow meter, and then right next to me is the X143HP, the hydropower generator, plus a 1-inch model 90-01 pressure reducing valve. Let's go over this, the 16-inch valve first. All of the information on this valve is on this brass tag right here. It says inlet in 4 different languages. The top number tells us the size, the catalog number, the stock number, and also a 2-letter date code. It tells us when the valve was manufactured. All of the controls for this valve are on the other side. This is a pretty straightforward pressure reducing valve. It takes the high upstream pressure, which is about 90 pounds or so currently, and reduces it down to approximately 45 pounds. And that's its job. It doesn't know the flow, it doesn't care about the flow, it only reduces the high upstream down to a manageable low pressure. On top here we have a position indicator. This is a visual indicator. We have a stainless steel rod inside the sight glass that tells you approximately what the main valve position is. On the other side we have coming out of the inlet body port, we have a 3/8" ball valve. Next, if we follow the tubing, we have a what's called an X58 restrictor. That's a fixed orifice restriction. After that, we have a 3/8" female T. This is our cover connection, and part of that connection goes to the cover connection, or the 3/8" ball valve on the main valve cover. After that 3/8" T, the cover connection, we have a 3/8" model CRD. This is a pressure reducing pilot. It is direct acting. And right off the discharge of the pressure reducing pilot, we have a pressure gauge. And so that tells us directly what the downstream pressure is. As I mentioned earlier, this valve in the other inlet body port has a X144E flow meter. This gives us the full range of flow up to 0 to 13,000 gallons a minute. This valve also has a X143 hydropower generator. What we're doing here is we're producing 24-volt loop power, and we're just taking the pressure from the upstream side, running it through the turbine generator through a pressure reducing valve to limit the amount of downstream pressure that we're flowing through our generator. And then this goes through the tubing here connected to the downstream body port. And so we can ensure that we're not going to overpressurize the downstream with our pressure reducing valve here. Okay, that will conclude the video training for the 16-inch model 90-01 pressure reducing valve. Thank you very much.
Okay, I'm Roger Lay with Clay Valve, Technical Product Specialist. Jeff Varney just introduced the main valve and the generator. I'll just touch on the generator specifics. As Jeff said, the inlet pressure is coming up from the inlet body capping through a filter, through the generator, which, as you might notice, is nothing more than a pump in reverse, and then the generator itself sending the power output to the panel over on the end here. Now this actually generates AC power, which is then rectified in the panel to DC, and then a charge controller to charge up batteries. So in a lot of respects, this is very similar to solar. We're just charging up the battery, the energy storage, just like solar. Whereas unlike solar, we have no solar panels exposed for vandalism or any other damage. So this is generating the power. The valve here, its purpose is to limit the downstream pressure. It's not likely, but if the demand goes very low downstream, or if they shut off the irrigation system completely, this valve will completely close and protect any piping from being overpressurized. That's the purpose of this valve right here. The generator is generating. The important thing to understand is the filter. I'm not that familiar with water quality. I understand it's reclaimed. It should be relatively clean, but periodically they should probably flush the filter here, because if this gets clogged, your output from your generator will decrease. So that's something probably a good idea to monitor, maybe maybe within even 2 weeks, just to see how quickly it's clogging. Thereafter, you can judge the frequency and then maybe even introduce a blow-down valve to manually just flush it. Would be a good idea. So that's the key thing, is monitor this filter. I understand that the pressure drop across this valve is somewhere near 40 psi. Our engineering charts show that that output is close to 100 watts of power. The equipment they're powering here is far less than that, so we have lots of reserve. But this is our high power generator. Right here on the valve, as Jeff mentioned, the flow meter itself is very low power. It's only 4 to 20 milliamps, loop powered, so it's very low power requirement. And it's a 2-wire transmitter, just like these pressure transmitters, so it's a very simple device. So we'll now go over to the panels and describe the electrical equipment. Okay, we're now at the generating panel, which is coming from the generator at the valve. This is the battery compartment below here. There's two 12-volt batteries. This is a 24-volt system, so these batteries are wired in series. So 12 plus 12 is 24 volt. The charge controller itself automatically is detecting this and knows that it's a 24-volt system. So we didn't have to make many changes in the programming, and we'll go into that in just a second. But the AC comes in here to a DC rectifier that's rectified to DC into the charge controller. Now this is special, even though it says solar on it, it's really specially engineered for hydro generator optimizing power. So it's borrowed from the solar industry, but it's with specialized software to manage and optimize the generator output. And then that's connected to a display. The other device here in the box is simply a low voltage disconnect. If the power is reduced such that the batteries get below about 11.5 volts, this will disconnect the batteries and save the batteries so they don't get damaged if there's a problem. So that's the only purpose of this equipment here. Here on the circuit breakers, we have the AC coming in from the generator to the DC rectifier. The diversion load, which is a heater we'll look at next, that when the batteries are full, the generator keeps running and diverts the energy to a diversion load heater next to our panel here. The load itself, 24 volts, they're running their SCADA off to the side here. We'll go into that next. So that's the 24 volts powering all of the SCADA and instrumentation. There is a battery temperature sensor. The battery temperature wiring is connected right here. You can actually read the battery temperature on the display on the front of the panel, but that's the wiring for the battery temp, and of course the battery itself is connected here. So let's go to the front display itself. I don't know if you can zoom in on this, but this is the display for the charge controller. The battery right now is 26.2 or about 13 volts per battery. It's charging at the moment. It's shut down after an equalization process, but normally you would have a positive amperage here. And so basically we're at, per battery, a good 13 volts. We can go into this menu system and read the battery temperature, the volts and amps at the same time, so you can calculate watts power output to verify that it's doing its part. And by the way, the less the differential, that may explain. I just noticed we're not actually running. We probably lowered our differential below the minimum. So right on camera, we actually prove that the generator does need 25 to 30 psi pressure drop. So as he increases the pressure drop, this should start kicking into a positive. In fact, it's starting to flash. Now it's going positive. So we have a dynamic increase in differential. The generator's kicking into a positive amperage as we increase the differential across the valve. So you could actually see it working as we change the differential across the valve. So now we're back charging up rather than a negative amps. So before, we just noticed at one point the voltage was just short of 30 volts. The amperage was just shy of 4 amps positive, which is well over 100 watts of power being generated. Right now it's just slightly over 4, and we're just still 27 volts. So it's pretty close to 100 watts of power being generated, which is matching our specified performance. Wanted to make sure that all users should get familiar with the very detailed manual that goes into the hookups, the wiring, the components, and setup programming. We've gone through that today to verify all of this performance. The hookups, the filter hookups, the wiring for the diversion load, and battery hookups for 12 and 24 volts. Whether you have here's an example of a 12 volt with 2 batteries. Here they have a parallel system with 24 volts. This is showing 4 batteries. They have 2 batteries here wired in series to get 24 volts. So this is a 24 volt system. And of course you can run all types of instrumentation here. We have a panel meter and sensors. They could add to this valve a motor on top of the pressure reducing pilot to remotely change set points if they ever wanted to. There's plenty of power here to run that type of equipment. So that's the very detailed manual that we recommend users get familiar with. We want to cut to the diversion load on the next panel. That should be in a separate panel because it generates heat. Okay, this is the panel just right next to the main control panel. That is the diversion panel. One thing I do like, they have a sunshade here. That's a very good idea to protect from elements, rain and whatever. As you can see, this is obviously not a waterproof enclosure. It's inside an enclosure that is vented, so the heat will have a chance to pass out of this panel. But when the batteries are full, this will warm up and may become hot, so that's why there is a warning. We actually changed the wiring for 24 volts from 12 volt internally. The electrician has finished that already, so it's already connected, and I feel even a little bit of warmth already coming from this. So I can touch it, but it's warm already. So it's already starting to divert some of the energy. So now we'll go to the telemetry panel. This is the equipment being powered by the generator and the batteries. And as we can see, there's not a lot here. It's pretty low power instrumentation. The flow meter from the valve is coming into a digital panel meter, reading out in million gallons per day. Right now we're just below 6 mgd flow rate. This panel meter shows not only rate but also a local display of total. So right now, since I zeroed it out less than an hour ago, we're up around 0.4 million gallons. We're about 400,000 gallons. Now, I don't know if you can hear it. I'll just toggle back to the rate in million gallons per day. You can hear a little click. There is a pulse output from the meter itself to a little relay that clicks just shy of every 10 seconds. Every pulse is 500 gallons. That is coming into the telemetry PLC that they're remotely monitoring and totalizing through SCADA. And then they have the radio here being wired up to remotely read all of this information. And as I understand, they have upstream and downstream pressure coming into the panel here. We have originally programmed the meter itself. It comes from the factory in gallons per minute scaling. Since the customer wanted MGD, we rescaled to show MGD, not GAL, and we rescaled on a 16-inch valve. The full scale is 14,000 gallons per minute, which equals just a little over 20 MGD. So we rescaled in the programming, so it's already finished scaling. We scaled the total to read in millions of gallons, and they're just counting it here. So it's very simple setup, and all of the documentation is available on our website, and we will send the customer a full programming manual. This is on the display itself, showing the setup wiring for the display, which they have already finished, showing some of the wiring internally here. They brought the 24 volts to terminal 1 and 2 and bypassed our AC power supply. This is a DC system anyway, which then powers the flow meter on the valve, which then goes into the panel meter that right here. Now a 16-inch valve here is in the chart right in the same literature. Full scale on a 16-inch is 14,000 GPM, but we rescaled that for MGD. So that's already finished, and it's very simple setup. So it's all working now, and want to mention that all of this information we're showing here is at claval.com, cla-val.com, and just punch up any of the equipment, the X145 meter, the E-display, the X144 flow meter, and of course the Claval main valve. That's a 9001. So you can just punch that up and pull up all of this information right here. So I think that's it. It's a very nice system, running very well. So thank you very much.